by 1997, and by the fall in particular, I had been picked by our team to analyze our first really large sample of supernovae, about 16. And having done all the steps in the analysis came the moment of truth where the deceleration rate, which we write in the variable Q naught, set by the supernovae, would then imply how much mass was in the universe. If it was decelerating a lot, if this was a big number, then the mass of the universe would be a big number and the universe would recollapse. So I wrote a simple computer program to tell me what the answer was, and hadn't yet noticed that something very strange was going on. So this is a key page from my lab notebook. When I evaluated what the mass of the universe was, I got an unphysical, nonsensical answer, a negative value. That wasn't even one of the possibilities. It wasn't in column A or column B. It was very strange, and what it meant was if this term was negative, that really meant this term on the left was negative. That is, the universe wasn't decelerating, it was accelerating. And I just hadn't noticed it. And when you ask a computer sort of a dumb question, you get a dumb answer, which is the universe would have to have negative mass. Now, the real reason is because I assumed this thing that Brian had described, this cosmological constant, didn't exist. And so I quickly realized that the other way to get this number on the left to be negative, for the universe to accelerate, is to have an overwhelming amount of this term on the right, this Einstein's cosmological constant. And so a few days later, I began considering whether that indeed was required by our data. And another calculation showed, yes, at what we would call good confidence in the statistics, this wasn't a fluke. At 99.7% confidence, this is what our data was showing. So this was extremely surprising. I assumed, Brian said, what did I do wrong? That was exactly my thought. What did I do wrong? I can't believe we didn't even get close to the right answer. And so I went through a series of checks, but I couldn't find what I had done wrong, and then began to talk to the team about what we as a group had done wrong. And this was a very fun time and exciting, and the best way I can bring my colleagues who are out in the audience back onto the stage with me is to share with you a couple of days of very excited, very tense discussion back and forth over email. And so that's what I'm going to do now. So this was, you can imagine, just upon seeing these results more widely in the team, Alex Filipenko started out the dialogue. Adam showed me fantastic plots before he left for his wedding. Our data imply a non-zero cosmological constant. Who knows? This might be the right answer. I should say I got married just a couple days before this, so it was a very exciting time. Bruno Leibengut from Germany wrote, concerning a cosmological constant, I'd like to ask Adam or anyone else in the group if they feel prepared enough to defend the answer. There is no point in writing an article if we are not very sure we are getting the right answer. Brian Schmidt, I agree our data imply a cosmological constant, but how confident are we in this result? I find it very perplexing. Bob Kirshner, I am worried. In your heart, you know the cosmological constant is wrong, though your head tells you that you don't care, and you're just reporting the observations. It would be silly to say we must have a non-zero cosmological constant, only to retract it next year. Mark Phillips from Chile wrote, as serious and responsible scientists, we all know that it is far too early to be reaching firm conclusions about the value of the cosmological constant. John Tonry from Hawaii reminds us, who remembers the detection of the magnetic monopole and other gaffes? On the other hand, we should not be shy about getting our results out. Alex Filipenko again, if we are wrong in the end, then so be it. At least we ran in the race. I came back from my wedding, repacked to go to my honeymoon, and typed out a quick email. The results are very surprising, shocking even. I've avoided telling anyone about them because I wanted to do some cross-checks. I have. And I wanted to get further into writing the results up. The data require a non-zero cosmological constant. Approach these results not with your heart or head, but with your eyes. We are observers, after all. And Alejandra wrote, very amusing, if Einstein made a mistake with the cosmological constant, why couldn't we? I could never tell whether this was a vote of confidence or a statement that if you're wrong, you need good company. And then Nick Sunsef wrote, I really encourage you, Adam, to work your butt off on this. we need to be careful. If you are really sure that the cosmological constant is not zero, my God, get it out. I mean this seriously. You probably never will have another scientific result that is more exciting come your way in your lifetime. And of course, Nick was, as usual, right. So after about another 6 or 8 weeks of trying everything we could to knock the result down, we felt we couldn't and that we had to come out with the face value interpretation. And we published this paper, Observational Evidence from Supernovae for an Accelerating Universe and a Cosmological Constant, implying that the universe was accelerating at a degree that about 70% of the energy of the universe would be in the form of this cosmological constant, or more generally dark energy.